Now we have problem number 7.2. In this problem, he is telling the cross section shown in figure below is from a simply supported beam that carries a positive bending moment of 11.3 kilonewton meter. Okay, see here he is telling me the bending moment is how much? 11.3 kilonewton meter. It has been determined that I, that is moment of inertia, he has already calculated the moment of inertia and given no need for us to do the calculation. Okay, if we have to do the calculation, first we have to find the centroid and then we have to calculate area moment of inertia. The centroid of the section is 81 point, see here it is here, 81.25 millimeter up from the bottom of the beam. That is, he is telling me from where? From the bottom of the beam. Let me show you the beam cross section little bit big. See here, from here he is telling me, the centroid is here, present here. See, this distance is 81.25. He is telling me. Okay. Now what he wants, compute the stresses due to bending in the beam at axis A to F indicated in the figure below. So he wants me to find out the bending stresses at different points. What are the different points? You have point A, Wahid, point 2, point 3, and then again he wants at what? He wants at point 4, is it not? At these points, he wants us to find out the stresses, bending stresses. Okay. We have the formula. Formula is very simple and we know it. M by I is equal to sigma by y. Okay. So now what are the things given to us? He has already given m. We know m. We know I. So what we need to do? We need to only find the value of, put the value of a, b, c, d, whatever it is. Just put the value here and then find out this value. Okay. That's what we want. Exactly. Previously we did a similar problem, right? That's what he wants. Here the dimensions are very clear. Remember, whenever we are taking y, this y is from where? This y is from the neutral axis. We are not going to go from the bottom, right? So we have one, that is, this one is what? This one is from here to here. We will call it as ya. Then the second one is what? Second one is from here to here. This is y b. Then for point C, this is y c. Okay, if you want to go up, then we have the other points also. Okay, so now let us try to find out the values now. So here already calculation has been done over here, so I need not have to redo it. I will just explain it. See, m is what? M is 11.3 kilonewton meter, is it not? So what I will do now, I will simply convert it into what? Kilonewton millimeter. From kilo it is 10 to the power of 3. From meter to millimeter is another 10 to the power of 3. So it becomes 10 to the power of 6. The value of I he has already given. You can ask me, teacher, why you convert? Because I is in millimeter to the power of 4. So, and the value of y max is how much? Let me just go to this big picture and see. Here he says here, see, y max is how much? 81.25, is it not? So that 81.25 is there. He is calling here it as C. I can also call it as y maximum right now, or you can simply call it as y also. Okay, because it is, which point is that one? It is called as point A, isn't it? So y I will write it. Now he wants us to find out what? Sigma, he wants to find out stresses from A to F, from the beginning till the end. He wants from for all the points, right? That is from where? Here, and then again this also he wants. Okay, at this level also he wants. Understand? This also he wants. I can call it as Y F, or so we can even call it as YC, whatever it is. And then again this distance also we have to find out YE. Okay. Now let us go back here and let us just see. Now we know What are the things we know? Sigma at point A. Sigma at point A is what? Sigma at point A we need to find out. Sigma max is equal to M into CA by I. Okay. So how did I get it? I get it like this. See, M by I is equal to sigma by Y. Is it not? So now if I want sigma, sigma is equal to M into Y by I. So here in this, he is just showing it not as Y, he is showing it as C. Understand? YA, instead of YA, he is writing CA. That's all, nothing other than that. Okay. Now I have the value 11.3 into 10 to the power of 6 is there, and then 81.25 is there. The value of I is already given in the problem, 7.1 into 10 to the power of 6. So what is happening now? This 10 to the power of 6, 10 to the power of 6 gets cancelled. So now we can just simplify it. If we simplify it, it is coming as what? Sigma max is equal to 129.3 Newton per millimeter square. I can also write it as megapascal. Okay. Since it point A is in the bottom, and the beam is bending like this. See here, the beam is bending like this. So what will happen? In the bottom you have tension. Understand? So it is tension. That's why it is written over here, tension. Okay. Now let's go to next point. Okay, which is your next point? Your next point is y at this point, is it not? So I need the value of yb. What is the value of yb? The value of yb is how much? 81.25 Nagas 25. This gives me how much? Just a minute. 25.00, you're right. Otherwise, 25 is there in the top also. You shouldn't make mistake. Okay. So 81.25 minus 25, that gives me how much? 56.25. 56.25 is the value of YB. Okay, YB. Or CB. Here he is calling it as CB. Let us call it as CB only. Now let's go to the problem. Here now let us see. Sigma at C is YCC. Yeah, 81.25 minus, what did he do here? YB is 25, is it not? Yeah, YB is 25. He did not write for B, did he write? No, for B he did not find out. For B he did not find out because he is asking us in the question. What he is asking us in the question? He is asking us in the question from A to F, is it not? So this means I have to find out at A, I have to find out at this one also, B also. Okay. So here B is missing. Let me just write the value of sigma B here so that you can calculate by yourself. Sigma at B is what? Sigma at B is sigma max is equal to M by I multiplied by C of B. I write Y of B, he is writing C of B. 11.3 into 10 to the power of 6 divided by 7.1 into 10 to the power of 6 multiplied by YB. We calculated it here. How much is that? 56.25. Correct? 56.25. So this gives me how much? Let me just see. This gives me this 10 to the power of 6. 10 to the power of 6 is gone. 11.3 divided by 7.1 multiplied by 56.25, that gives me 89.5. Again, this is also tension, okay, because it is also below the neutral axis. Okay, see here, where is your neutral axis? Your neutral axis is here. This point is below neutral axis, is it not? So YB is done. 81.25 minus 25 is 56. That's fine. Okay, this is also done now. The P is Done. Now let us go to YC. So YC is what? YC is again this value. This value is how much YC? YC is nothing but from top to bottom is 81.25 minus 15. Minus 15. This gives me how much? 81.25 minus 15 is equal to 31.25. Okay, 31.25. Now what I need to do? I need to just go here and see sigma at C. See here, 81.25 minus 15, that is 31.25 m into yc by I, so that I am getting it as what? 11.3 into 10 to the power of 6 into 31.25. So when you do it, you are getting a stress of how much? Let me just check it. 11.3 divided by 7.1 multiplied by 31.25, that makes me 49.74. Okay, again this is also tension. Okay, so now we finished at what? We finished at D also. I mean, this is done, this is done, this is also done. What about D? At the point D, it is 0. Okay, why it is 0 at point D? Because point D is here, neutral axis is there only, is it not? So you do not have any value of y. Okay, so what can you say? You simply say that it is 0. Okay, then we have got stress at F, that is at the top. At the top is, again go back. At the top, total distance is how much? Total distance is 129, isn't it? So what I should do? YF is equal to total distance is 125 minus 81.25. This gives me how much? 125 minus 81.25 gives me 43.75. 43.75 millimeter. Okay. So I have millimeter here. So let us just go back here and see. See, 125 minus 81.25, so I'm left with 43.75. And again I will go here, I will write, see, when you are using C, this means the maximum stress we are talking. Otherwise we are writing the middle points as we can see YC we are writing, is it not? And then again in another place also we are writing, so actually we should write this one as YB only. Let me write it as YB. Okay, YB only, let me write. Okay, and now here you see CF means what? It is the farthest point here. Okay, and CA means it was the farthest point here. So where the stresses are maximum. See, when you do it, you are getting a value of how much? Minus. We are writing the sign minus for the reason because it is compression. That's all, nothing other than that. Okay. So now I will just go and write. This is what? This is compression. See here, this is compression. So here also he did. So now the stresses are going from the bottom, from tension to the top, they are going in compression. Understand? It will be 0 at the neutral axis. It is 0. Okay.